Vamos a comenzar. Okay. Okay, we're covering the ISLM model. Esos son los websites que te di la semana pasada. Okay. So what Keynes does, he basically takes everything he understands about the economy and and economic theory at the time, and he makes some assumptions. And the biggest assumption that he made are right here: fixed nominal wages and fixed nominal prices. And that allows for fiscal policy and monetary policy to have real effects in the economy. He called them exogenous variables, which means they're outside the system. So we have to have real output and nominal interest rates. Real interest rates in the presence of fixed prices can have a real effect. Hold on a second, guys. We'll be right back. Sorry, my dog is going crazy. Okay, so here we go. The demand for goods consists of, right, two things: consumption and investment. We're going to ignore some of the details by not distinguishing between investment and consumption goods, but merely talk about aggregate output. That is, aggregate output or income, Y, is going to equal consumption, C, plus investment, I. Now, if you guys did what I told you and you went and looked at some undergraduate ISLM models, you'll see that income equals consumption plus investment plus government spending plus net exports. In our case, we're assuming a closed economy. So we're going to break down those two factors of national income, consumption, investment, and we'll start by looking at consumption. We're going to assume that consumption is a function of interest rates and income, right? In contrast with real business cycle models where consumption depends on wealth rather than income. We'll talk about that later. And later on, in some of the critiques of Keynes, Milton Friedman and others used wealth rather than income also, right? He assumes that the marginal propensity to consume is less than 1. What that means is all the income you earn, if you earn $100, right, you're going to spend less than $100. In other words, you're either going to save some, right, or you're going to spend all your money. In this case, we're going to assume there is some savings. So therefore, the marginal propensity to consume, the amount that you consume out of your income, is less than 1. Right? Which is half. We shall also assume that the substitution effect dominates on average, so that increases in R increase savings and reduce consumption. In other words, that increase in R isn't going to increase your income so much that you'll spend more. Rather, it's going to encourage you to save more to take advantage of the price of money. In other words, to get more return on the money that you invest. So having determined the level of savings, households then allocate savings between money and interest-paying assets, right? There's two factors. One is higher income increases the demand for money for transaction purposes. And that really wasn't a big deal. Number two, higher nominal interest rates reduce the demand for money. Again, that one's not such a big deal with fixed fee. what he talks about, what the author doesn't talk about, is something known as speculation or speculative purposes, where people invest because they they assume that interest rates are going to go lower, so they'll buy bonds, or vice versa. Okay. But what we're concentrating on now is income, which has a positive effect on money demand, and interest rates, which have a negative effect. So L of R is negative and L of Y is positive. Right? Next, let's talk about investment. Keynes assumes that both interest rates and income affect investment in much the same way that they affect consumption. Right? When interest rates go up, people are going to buy more. Excuse me, buy more bonds. When income goes up, people are going to have more money and they're going to invest. When interest rates goes up, people, sorry, I said buy more bonds, are going to borrow less money, so investment will go down. So interest rates have a negative effect on investment. Let's make that clear. Remember, this is real investment. And income has a positive effect on investment. So the signs are exactly the same as with consumption. Here the author adds something, a shift parameter known as alpha, or that he calls alpha, that correspond to shocks, or what Keynes calls whims, herd instincts, or animal spirits. In other words, people, for some reason, just either invest more or less at certain points of time, exogenous of the model. It's just a shock to the system because people, for whatever reason, change their attitude. Okay. Preguntas? Okay. So we have the basic model now. We have y is equal to c plus I, where I is right here, is a function of interest rates and income, and investment, which is a function g of interest rates and income, and the shift parameter alpha. So I'm going to take this function right here. Ustedes pueden ver el cursor, ¿no? La flecha en el PowerPoint. Okay. Well, I'm going to totally differentiate this function, right? So here I have first with respect to y. So I have the change in f with respect to r times dr dy, right? In other words, how y affects r. Over here, I have the change in f over y, how y affects f directly, and the same thing with income. Now notice that I didn't include alpha here. But I have d of r, d of y here, and d of r, d of y here, because y affects both investment and consumption not only directly, but through interest rates. So solving for d of r, d of y, I get the following. I have 1 minus the change in consumption over the change in income minus the change in investment over the change in income, divided by consumption over the change in the interest rate, plus investment over the change in the interest rate, where of course f is a function for consumption and g is a function for investment. Then our assumptions on f and g imply that the denominator is negative, right? Because, well, we already said that this is that that interest rates affect consumption negatively and investment negatively. So negative plus a negative is, of course, negative, right? It's also assumed that the marginal propensity to consume plus the marginal effect on higher output on investment are less than 1. So we assume, that this partial and this partial are less than 1, so this whole thing's negative. So we have a negative over a negative, which makes this positive. In that case, the IS curve will be negatively sloped in the YR plane. And so this is the IS curve here. I also have an LM curve that we'll talk about shortly. But the IS curve is negative. That is, when interest rates increase, national income decreases. On the money side, right, we saw a while ago, we have the demand for money, L of RY, is equaling the supply of money, which we assume is determined exogenously, at least for now. I totally differentiate this with respect to Y. First, Y affects R, and then R affects the demand for money, plus the change of Y directly on our demand for money. I set that equal to 0, and I solve for dr dy. Oops, going too much. So dr dy is equal to the change in money demand over Y divided by the change in money demand over R. This we saw in the denominator is negative, but what we have in the numerator is positive. But we have a negative sign right here. Can you guys see the negative sign? It's hard to see. Okay, so I have negative and the positive makes the denominator negative, divided by the numerator, which is negative. Negative over negative gives me a positively shaped YR plane. So, oops. Okay. So going back up to our graph, I have my negatively sloped IS curve and my positively sloped LM curve. IS stands for investment savings curve, LM stands for liquidity money. So now we can do a little bit of comparative statics with our IS-LM diagram to study the effect of exogenous variables like that shift parameter we were talking about. And also an increase in money supply, which we assume is exogenous. So an increase in the money supply is going to shift the LM curve to the right, right? And it'll shift the LM curve to the right because, right, out here, when this increases, this has to increase to keep the economy, so it shifts to the right. Output will increase, and therefore we'll have pro-cyclical movements in the money supply. And the problem with that is R moves counter-cyclically, and as we saw when we did the evidence on the business cycle, that's not clear that interest rates move counter-cyclically. Our observation, right, of the data for interest rates tended to be relatively high as the economy went into a downturn, but then tended to decline along with output as the recession got underway. Similarly, low interest rate tended to precede periods of rapid output growth, but then rise along with GNP at business cycle peaks. So it's not clear that it moves counter-cyclically. Right? An increase in the shift parameter alpha, which will move the IS curve to the right and leave the LM curve unaffected. Therefore, we'll have a pro-cyclical movement in these animal spirits in both output and the interest rate, which is usually thought to be more consistent with the evidence, although we noted the correlation between interest rate and outputs are not very strong. Right? So to explain the pro-cyclical movements in money supply, we could add the assumption that monetary authorities accommodate expansions, i.e. when we're going into expansion, high interest rates follow the investment boom. The authorities expand the money supply. So long as the expansion of money supply isn't too large, interest rates can still rise. In this scenario, the causality will run from interest rates to money supply rather than money supply being the exogenous factor, which is essentially what we were assuming. Okay. So we can also examine the effects of changes in exogenous variables using algebra. Right? So we collect our two terms, right? Y equals C plus I, right? Where C is a function of R and Y, and I is a function of R, Y, and alpha. And of course, where money demand equals money supply, where money demand is a function of R and Y. So I take this and I set up a matrix. So I have, I'm sorry, I totally differentiate it like we did before over here. First, for money demand, and for our IS curve. Right. So I take those and I set up a matrix equation. Here I have 1 minus f of y minus g of y. Here I have negative f of r minus g of r. Where f of y is simply the partial of f with respect to y, and g of y is simply the partial of g with respect to y. L of y is a partial of money demand with respect to y. L of r is the partial of L, money demand with respect to r. Times dy d alpha times dr d alpha equals g of alpha, and of course 0 because... ¿Perdona? Dime, Gisela.
No, como que se está oyendo como si fuera otra persona hablando.
Ahorita estaba oyendo a otra persona también. ¿Tú oyes algo, Joshua?
No, lo que estoy viendo, lo que me acaba de llamar Carolina, que por favor la llame, porque está conectada desde su hogar y que tiene mejor internet.
Tú dices que la llamo, que la invito, o que la llamo por teléfono.
Exactamente, que le invites por aquí.
Okay. Como estaba diciendo, or like I was saying, basically now we have a function to see how alpha affects income and interest rates, right? So the first thing I want to do to solve this is take the determinant of this matrix right here, the big matrix. Hola, Carolina, ¿me oyes?
Sí, ya escucho.
Gisela, ¿me oyes todavía? ¿O todavía estás oyendo a otra persona? Okay. Okay. Let me go back a couple steps. So now that Carolina joined us, it probably wouldn't hurt anyway. I'll go quickly. This is our equation for consumption. Consumption is a function of R and Y. The marginal propensity to consume is less than 1. That means we get income and we save some of it. That means we don't consume 100% of our income by assumption. Money supply equals money demand, where money demand is also a function of R and Y. Investment, right, is a function of R and Y, and it has the same size as consumption. It's R negatively affects investment, and Y positively affects investment. And we assume a shift parameter, right? Animal spirits or whims that also affect investment. So going here, so Y equals C plus I. I plug in those functions and I get the following, which gives us our IS curve, downward sloping. And I do the same thing for our LM curve with money supply equals money demand, which is money demand here, L, money supply here. I totally differentiate that, get 0, and I get negative times positive over a negative gives me a positively sloped LM curve, right? Which is this curve here. Okay. we looked at how changes in money supply might affect the economy, and we look at now how changes in our shift parameter alpha will affect money supply using matrix algebra. Here are two equations, y equals c plus I, where, of course, c is a function f of interest rates and output, plus investment, where investment is a function g of interest rates, income, and the shift parameter alpha. And I have money demand equals money supply, where money demand is equal to interest rates, or sorry, well, money demand is a function of interest rates negatively related to money demand and positively related to national income. I totally differentiate this, right? Like we did before, and I set up a matrix equation, right? Where f of y is the derivative, the partial derivative of consumption with respect to y, g of y is the partial derivative of investment with respect to y, f of r and g of r are partials of investment with respect, I'm sorry, consumption and investment with respect to interest rates. And of course, these two down here are partials of money demand, first with respect to y and with respect to r. And I have dy d alpha, dr d alpha, right? So we can see how the shift parameters affect. And of course, finally, I get g of alpha and 0 because the alpha, our shift parameter, is not in our money demand equation. So therefore, multiplying anything by changes in alpha are going to give us 0. Okay. Preguntas. Okay. Carolina, yo estoy grabando esto y la voy a dejar perdón, en YouTube.
Okay.
Y luego la bajo y si la quieres te la puedo mandar de nuevo. Pero también yo creo que la puedes bajar de YouTube. Okay. So I take the determinant of this, excuse me, of this 2 by 2 matrix. So this times this, right? Minus this times this. So I have two minuses, which gives me the plus. So I know this right here is positive, but this is negative. So this first, excuse me, this first term is negative. I know f of r is negative, and I know g of r is negative, and L of y is positive. So the second term is also negative. So the determinant of this, excuse me, of this matrix is negative. So now I want to go ahead and substitute, right, in the two columns to see how dy d alpha plays out. So the determinant, right? Now I hope you guys went last week through and reviewed matrix algebra. I plug this in here, so I get g of alpha L of r minus 0 times negative f of r minus negative f of r, which is 0. So I get change in y, change in alpha equal to g of alpha L of r. We know the determinant is negative. G of alpha is positive by assumption. L of r is negative. So we have a negative over negative, which means this is positive. So our shift parameters for income is positive. Okay. For dr d alpha, I plug in this column right here. So I get 1 minus f of y, g of y times 0, and L of y minus L of y times g of alpha. Okay, so I have it here. So minus g of alpha, L of y. G of alpha is positive by assumption. L of y is positive. So I have negative times a positive over negative. Negative over negative gives me positive. So alpha affects both income and nominal interest rates positively. We can also see how it affects consumption. This next slide. So dCd of alpha, right? It's going to equal f of y, change of y, change in alpha, plus f of r, change in r, change in alpha, right? So this equation is greater than 0 if f of y is greater than f of r. In other words, if income has a greater effect than on consumption, interest rates do, and if L of r is greater than L of y. In other words, interest rates have a greater effect on money demand than income does. So if those two things are true, which we're going to assume, right? Okay. Oh, and also, investment with respect to alpha is going to be basically investment is got to equal the it has to equal savings in this closed economy, since there's no government and there's no exporting. So savings is simply y minus c, which we can write as 1 minus f of y dy d alpha minus f of r dr, excuse me, f of r dr d alpha, and that's going to be positive. So we have this being positive with our assumptions, and this being positive. So the shift parameter alpha affects consumption positively and affects investment positively. Preguntas? Okay, so that we have both pro-cyclical consumption and investment in response to a shock. We can also look at what happens to the ratio of investments in the economy with response to the shock. And basically, just doing the math, I get y to the negative 2 y di d alpha minus I dy d alpha, which I can rewrite as follows: y to the negative 2 y 1 minus f of y, plug in, minus I dy d alpha minus y to the negative 1, we'll have a y on top, f of r dr d alpha. But we know that y times 1 minus f of y, in other words, savings, minus I, equals c minus y f of y, and that c times 1 minus y over c, partial of f, partial of y, has to be positive. And this we get by the chain rule, because this has to be less than 1, by our assumption that the marginal propensity to consume is less than 1. So this is positive, consumption is positive, so the whole thing has to be positive. And putting that, remembering that this is, knowing that this is positive and that that part is positive, right? So the final inequality follows from Keynes' fundamental psychological law, thus that the investment output ratio moves pro-cyclically, i.e., when we're doing better in the economy, a larger percentage of our income gets invested. And in response to a positive shock, right, that appears to be the case. Of course, it depends how you measure shocks and whether they're positive or not, or there was active. Okay. Preguntas? Okay. Let's talk a little about now the dynamic and stochastic difference equations, right? So what he says is that even simpler Keynesian model than the ISLM we've been discussing assumes that nominal interest rates, in addition to nominal prices, what we did last week, are fixed. It takes I and C as functions of y and looks for a level of output y corresponding to equilibrium in the product market, right? This is the Keynesian cross, that if you did the undergraduate, if you did the undergraduate lectures last week, you would have seen. So here we have y on this axis and C plus I on this axis. In this case, if it was undergrad, it'd be C plus I plus G. So in other words, where national income equals national output is our equilibrium. So here I have C plus I and Y star. This is our equilibrium output and income. Where they cross, that's a Keynesian cross. Here I have C of Y, right, positive function, and I have I of Y, also a positive function of Y. So using the simplest model, we can see how dynamics is introduced and how that produces a stochastic difference equation for Y with cycles in its autocovariance, like we talked about last week. The same result will carry over to a more complicated model, which allows for endogenous variation in interest rates and at least some variation in nominal prices. So using what I hope you've learned in econometrics so far, when econometricians estimate the consumption function, they found that the error term in a regression of C against Y displayed a high degree of autocorrelation. Right? To overcome the problem, they used lag consumption. So I have CT equals rho, which is the lag parameter, CT minus 1, plus alpha YT plus epsilon T, the error term. Thought I lost somebody. Where our error term, epsilon, is assumed to be independently identically distributed. One interpretation of the equation is that there's inertia in consumption and savings behavior. Consumption is determined partly by its value last period, but partly adjusted to current income. We shall discuss a more satisfactory microeconomic model of this equation later in the course. For the moment, treat it as the result of statistical analysis to get a good fit for the consumption function. This was how it originally arose, right? So taking that function and using the lag operator, I get the following. So I get C of t is equal to alpha over 1 minus rho L YT plus 1 over 1 minus rho L epsilon t. So we get rid of all the lag consumptions. Get an AR model. So dynamics was also introduced into the investment equation, right? The basic idea to do this was the accelerator model of Samuelson. Samuelson's another Nobel laureate. It's assumed that the required capital stock is proportional to output. The level of investment or desired change in the capital stock will then be proportional to change in income. So K of t is proportional to Y of t, and that means that we can write investment at some function of the difference between income in one period and income in the next. So we can write a beta, which is our coefficient, YT minus 1. I forget what this little wiggly term is, so I'm just going to call it a wiggly term. So the random error wiggly term represents the random exogenous shocks to investment. Again, we assume that the wiggly term is IID and uncorrelated with all the leads and lags in epsilon. Okay. So substituting the equations for CNI into the product market condition yields an equation for Y. So I get YT is equal to this minus this, which is our investment function, our consumption function, and then the two error terms, which upon multiplying through by 1 minus rho times the lag term, I get 1 minus, and putting YT on this side, or isolating YT on this side, 1 minus alpha minus beta YT is equal to rho minus beta rho minus beta YT plus 1 plus beta rho YT plus 2 plus wiggly line T minus rho wiggly line T minus 1 epsilon T. So basically what we have is now a model that we can estimate econometrically, right? We can attain some idea of the effects of these dynamic specification by substituting what he calls plausible values for alpha, beta, and rho. Empirically, estimated consumption functions will yield an alpha of 0.95 and a rho of 0.9. So long as the marginal propensity to consume is about 0.95. By the way, this is not the same alpha that we were using a while ago as a shock term. This is our intercept term. So with the marginal propensity to consume about 0.95, we shall take the example of beta equals 0.3, and I substitute the values, and I get the following. I get 0.605 YT equals 0.33 YT minus 1 plus 0.27 YT minus 2, wiggly line 0.9, wiggly line minus 1 plus epsilon t. Right. With that, we can find the autocovariances of the stationary distribution for y by squaring the last equation, this 27 here, and taking the expectations of both sides, and then successively multiplying 27 by yt minus 1 and yt minus k for any k greater than 2. In this case, taking expectations, noting that the mean of y here is 0, since the mean of epsilon and the mean of the squiggly line are 0, by assumption, those are error terms. So basically now we're thinking of y as deviations around the trend, sort of like we did when we looked at the data in those graphs. Notice first that by multiplying by the wiggly line and taking the expectations, I find that the covariance of yt with the squiggly line, the first error term, is equal to the covariance of yt minus 1 times the squiggly line yt minus 1, or 1.653 times the variance of that first error term in our investment equation, the squiggly line. So I can do some eigenroots here. So I get 0.184 gamma 0 plus 0.178 gamma 1 plus 0.828 sigma squared wiggly line, the variance of our error term in investment, plus the variance in our error term on consumption. So I get gamma 0 is equal to 0.015 gamma 1 plus 0.4508. I'm sorry. So these two equations can be solved for gamma 0 and gamma 1 as follows. I get these two equations. Also multiplying by 27 on both sides of yt minus k. K is greater than 2, taking the expectations, we get the ordinary difference equations, 0.605 gamma k equals 0.33 gamma k minus 1 plus 0.27 gamma k minus 2, right? So the roots and the characteristic equations corresponding to this are as follows. We got 0.994 and we got negative 0.449 for lambda 2 in the roots. So solution for the autocovariances are going to be gamma k a, which is some coefficient, times lambda 1 to the k plus b, some coefficient, lambda 2 to the k. So for constant alpha and beta determined, so that y0 and y1 are satisfied by the equations above. From the solution, we see that a small variance, exogenous shock in epsilon and squiggly line, can be multiplied into larger variable movements in y. Also, since one root is negative and the other is close to 1, y can display oscillations, and deviations from the trend, right? And can persist for some time. In other words, we can get recessions, depressions that'll last for a long time. The features of the solution are magnified for larger values of beta. For example, if I have a beta of 0.47, right, we get the following equation. So we get even more oscillation, right? A positive value for lambda 1, close to 1, and a negative value for lambda 2 that's close to negative 2. And here are the footnotes, and they're in the, excuse me. They're in, excuse me, they're in the in the notes and in the PowerPoint that I sent you. Okay. Questions? Okay. The last part of the equation, I'm sorry, the last part of the lecture, I'm not going to emphasize very much. And let me. So in other words, from this slide on, you're never, I'm not gonna put on a test. So from slide 31 to 38 is basically for you guys to get an understanding of the dynamics, but it's not going to come on the test. That material won't come. The material before it, of course, is fair game. Okay. Preguntas. Okay. Sorry. Oh, I didn't present it to you. I was showing you. Okay, let me say that again. From slide 31 to 38 is not going to come on the test. But, oops. But from slide 30, this part, to slide 1, it's fair game. Okay. So if there are no questions on this, I'd like to schedule class next week for Tuesday at 1 o'clock. Can everybody make that? Okay. I do it for Monday, but there's the assembly, and basically I'm hoping that I'm trying to get as many people to the assembly as possible. Okay. Hay preguntas. Okay, so tentatively Tuesday at 1 o'clock. Hopefully we can meet in person. Okay. I graded, well, I put up the grades for the tests. They're on the website. They're at the bottom of the web page. I don't know if you guys have seen them already. I'd like to talk a little about the test and some of the common mistakes that everybody made. Okay. So the first thing I'd like to do is talk about question 1A. I don't know if you guys have the okay. A lot of you guys, and I'm not sure if, is that backwards? You guys see that backwards? Oh, okay. I can't write it backwards. But basically, if you can see it, a lot of you guys made this assumption, and or it seems to make that assumption. I just couldn't tell. That is the result if you assume that C1 equals C2. And if you assume that, that's fine. But assuming this is assuming the result. I didn't take too many points off of that one because it's very minor. The other big error came in part 2. In part 2, Question D. Now, basically, what you had to do, and of course, you guys are going to see this backwards again, but I can't write backwards. So, in part C, almost everybody got this correct. Oops, right there. That's supposed to be a U, not an N. The marginal utility of consumption in period 5 over the marginal utility in consumption in period 10 was going to equal beta to the 5th power times 1 plus R to the 5th power. Almost everybody got that correct. But when I asked to explain, right, how the interest rate affects intertemporal consumption, almost nobody used what they got in part C. Basically, you use part C and say, look, that if interest rates go up, right, this number gets bigger. That means I consume more in excuse me, in earlier periods. Oh, sorry, later periods. Right. This is what you should have used for part D in question 2. And the last big mistake, here, I think I can write this one.
Excuse me, Professor, but the reason is that in the beta 10, I consume more than in the beta 5. There is a solution in that exercise.
I'm sorry?
Okay.
Say it again.
Ok, la contestación sería que la utilidad en beta 10, en la utilidad de beta 10, yo estoy consumiendo más.
No entendí bien. Ok. Básicamente, cuando los intereses suben, la razón de la margen perdón, the marginal utility, right, consumption in period 5 has to be greater relative to that in period 10, right? So using that, you answer that since the marginal utility in period 5 is greater than the marginal utility in period 10, I'm going to shift consumption from one period to the other period. Right? Okay. Okay, the other big mistake that everybody made is this. Can everybody see that in the chat? ¿La puedes ver, Grisela?
Sí, lo veo.
The only way that's true is if S is equal to 1. Now, this question is straight out of the notes. And you can get it on slide 20 of the growth theory notes. And well, let me share it with you guys. So this is basically it. I'll have 1 minus f of x prime. So f of x right? Minus S of X prime, which you know from the first part of B is equal to gamma plus delta X star. All I have to do is substitute that in, right? Take the derivative, right? And I get F prime, right? Take the derivative, set it equal to 0. I get F prime of X star is equal to lambda plus delta, which was basically what the question was asking for. Okay. And part C, the big error there was that when you guys took the derivatives, you didn't. Okay. Now notice here, when I take this derivative in equation 7 here, that here I'm taking with respect to xt. So when I do it with respect to xt, in that first part of the equation, let me go up and show you, I have xt here, right? So when I do it with respect to xt, the Lagrangian with respect to xt, I'll get it here, that's for qt, and here, xt. But over here, I have x plus 1, right? So what I have to do is I have to go to period 0, or period t, minus 1. So I'll get xt minus 1, xt minus 1, and here is where I'll have xt. So I'll get qt minus 1, 1 plus lambda xt, which is exactly, right, what I have here. Of course, the xt goes away. That's beta t minus 1, qt minus 1, 1 minus lambda. And it seems like nobody got the mechanics of that derivative, or what that, excuse me, what that summation sign was doing. In other words, I have xt in 2 places, but I also have xt in another place, but I have to go back 1 period and take the derivative here, which is why I get the beta to the t minus 1 and the qt minus 1. That makes sense, Carolina? Okay. That's it. Are there any questions? Okay. I will see you guys Tuesday at 1. Okay. I'm going to send you guys the link to this, to the YouTube video.
Okay. Thank
All
you,
right.
Professor.
Have a good week. I'll see you on Tuesday. 1 o'clock.
Okay.
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 All right. Bye-bye, everybody.